Are we so excited to have another algebra lesson? No, we're not. That's why I decided to decorate with ferrets today, because I need something to look forward to. This is Unit 2, Lesson 4, Quadratic Functions in Standard Form. A quick review of the last lesson. The vertex of a parabola is the turning point, and it's not always easily identifiable. It was in the last lesson, it's not this time. Standard form of a quadratic equation is y equals ax squared plus bx plus c. A, b, and c are all constants. A cannot equal 0, and exponents are listed in order from greatest to least. If you do not have this formula memorized, you need it in your notes. Quadratic equation resembles a U-shape parabola when graphed, and the axis of symmetry of a parabola is the line that cuts the U in half. Quadratics graphed in standard form. Unlike vertex form, quadratics graphed in standard form take a bit more than glancing at the equation to identify the key characteristics of the graph. Luckily, once the key characteristics, namely the vertex and the axis of symmetry, are located, the other characteristics can be identified as well. The standard form of the quadratic is represented in the form y equals ax squared plus bx plus c. Since the vertex cannot be identified by observation, use the equation x equals negative b over 2a. That formula is going to be really important this lesson. Write it down to solve for the x-coordinate of the vertex. Once the x-coordinate is found, substitute it back into the original equation, which is that quadratic in a standard form, to find the corresponding y-coordinate. If it doesn't make sense right now, don't worry, it will. Here's example 1. Find the vertex of the quadratic, and it's missing. I guess I need to go and fix that. And just like that, we had a screw up already. So here's a nice picture of Hyunjin for you. His Skizoo character is a ferret. Here's another nice one for you. Okay, example 1. Look, there it is. For some reason, it wasn't showing. I don't know why. I had to go fiddle with it, and it's back. Oh my gosh, look, it's gone again. Here's another nice Hyunjin for you. I'm particular to this one right here. He's a baby right there. He needs a babysitter. Okay, now that our formula's back, before solving for the x-coordinate of the quadratic, we need to identify a, b, and c. So in the standard form, the a is the number attached here. So a is 1. There's a 1 there, even though it's not written. B is negative 4, and c is negative 5. So see, a is 1, b is negative 4, c is negative 5. Now we're going to substitute the a, b, and c values into the equation to solve for the x-coordinate of the vertex. Look, our equation is gone again. You're going to get lots of eye candy today if it's going to continue to be like this. Yeah, you are. So we have our formula, we have the a, b, and c. So let me pull up my tools and get my little marker out. We'll use a different color today. So we have y equals x, which is 1. Okay, so our a is 1, x squared minus, oh, we already have all that garbage into the equation to solve for the x coordinate. We're just trying to get the x all by itself. I know what I'm doing now. Oh my goodness. Okay, we're just trying to get x by itself. So first we're going to add 5 to each side. Add 5. Okay, that's good. The formula is x equals a negative b divided by 2 over a. Okay, let me double check I got that right. So let's make sure I'm still doing this right. So to find the value of x, we need to have a negative b, which is negative 4. This is going to end up becoming just positive because 2 negatives make a positive. And then 2 times a, which is 1. That's going to end up being just 2. So we have positive 4 divided by 2, which means x is going to be equal to 2. Okay, so that's the correct way to find the value of x. So we already knew a is 1, b is negative 4, c is negative 5, and now we know x is 2. So to find the y coordinate, substitute the x value into the original equation. And would you look at that? My equation is gone again. More eye candy for you. Come on, give me my little pen. We have y equals, we know that x is 2, so 2 squared, I'm making sure I'm doing this right, I'm being careful this time, 4 times 2 minus 5, and we're just going to solve it as we would a normal problem. 2 squared is 4, minus 4 times 2 is 8, minus 5, that gives us 4 minus 8 is negative 4, minus 5, and that gives us y is equal to negative 9. So now we know our y value. So now y is negative 9. The vertex of the given quadratic is the x value, which is 2, and the y value, which is negative 9. Okay? So here's a check-in. If you feel like you can do it on your own, go ahead and do it. If you need to work with us, that's fine. Find the axis of symmetry of the equation, blah, when b equals 0. So if you think you can do this, pause it and give it a try. If not, just go ahead and continue on with us and we'll see if we can figure it out together. Okay? They say that x equals 0. Let's see if we can agree with that, because after all, I am the smartest person ever and I'm so good at math, okay? So I'm assuming what we do is we go y. If our formula is negative b, b is 0, we just saw that. Negative b, I'm going to have to go look at the formula again, divided by 2 times a. Okay, and it doesn't matter what a is, because anything that has a 0 on the top doesn't work. It's just a 0. So that's how they got x equals 0. That actually made sense to me. I hope it made sense to you. So the basic procedure for graphing a quadratic in standard form. These are the steps you're going to take. This should be in your notes. First, identify the x-coordinate of the vertex and the axis of symmetry using the equation. And it got moved on me, but it's actually there this time, so I'll just move it down for you. X equals negative b over 2a. Identify the coordinate of the vertex by substituting the x value into the original equation and solve for y, and then plot the vertex. Fourth step is to identify a point to the left and right of the axis of symmetry. Do this by choosing an x value to the right of the axis of symmetry. So they always go 1 unit. So they go 1 unit to the right. Find its corresponding y value, then reflect that point over the axis of symmetry. Connect the 3 points to form a U-shaped parabola. This should be somewhat familiar from the last lesson. If it's not, don't panic. We're going to get there together, okay? Here's example number 2. Graph the quadratic, and guess what? The formula is gone. You're getting so much eye candy this video. I'm tired. Okay, so here's our problem. The first thing we're going to do, wow, okay, I went and fixed them all. So before finding the x-coordinate of the vertex, note that a equals negative 1, which is right there, b equals 6, and c equals negative 4. We're going to use our formula and solve for x. Let me change the color of my pen. Okay, so we have, we need x is equal to negative b, which is 6, divided by, woo, that was pretty, 2 times a, which is negative 1, which is going to give us x equals a negative 6 over 2 times a negative 1 is a negative 2. A negative divided by a negative becomes a positive, so x is equal to 3. So you can see here we have our a, b, and c values, and now we know that x is equal to 3. Substitute the value of x into the original equation to solve for y. So we have y equals negative, we have 3, because that's the number we figured out, squared plus 6 times 3, our new value for x, minus 4. That gives us y equals 3 times 3 is 9. That negative does not get included in this. Okay, it's outside the parentheses. So the negative gets dropped down. We have 9 plus 6 times 3 is 18, minus, that's the prettiest 4, I don't know why it has a tail, y equals negative 9 plus 18 gives you positive 9, minus 4 will give us y equals 5. Whoa, so pretty. So now we have our y equals 5. The vertex is therefore 3 and 5. And right here, there should be a graph, which is not showing up because my life's a gift. So forget that, I'll just draw a really sloppy graph. So we go over 1, 2, 3 on x and up 1, 2, 3, 4, 5 on y, and that's going to be our vertex. Woohoo! I'm so good. And look at that, the graph's gone again. The next step is to identify points to the left and right of the axis of symmetry. Think of the axis of symmetry as a mirror. An x value to the left of the axis of symmetry is 2. And the reason they picked 2 is because we're dealing, ooh, that was pretty, with the x-axis, and we're already at 3, okay? So they just went to number 2. Okay, which is this point right here. So if they put 2 in for x into this original problem and solve it, they end up with 4 for the y value. So that's going to give us a point right there. Okay. Since the point 24 is 1 unit to the left of the axis of symmetry, then we can go 4, 4 for the other one, and then you make a lovely little parabola. I promise you, the real graph looks so much better. Hopefully it will show up on the next slide, and it doesn't. Finally, connect the 3 plotted points with a smooth curve. Notice that the parabola opens downward. This is because the leading coefficient, the value of a, is negative. This comes up in your quick check. Put this in your notes, because I won't tell you the answer. If a is negative, then it's a frowny face. I bet you're so glad that I'm teaching you this class, because I'm a grown-up. Okay, check in. Write a quadratic equation that has an axis of symmetry equal to 6. I did not expect you to do this one on your own, because this is one of those lovely questions it asks that has an infinite number of responses. So since the value of x must be 6 for the axis of symmetry to be equal to 6, use the equation x equals negative b over 2a equals 6. One possible combination is when b equals 12 and a equals negative 1. Therefore, a quadratic equation with an axis of symmetry equal to 6 is y equals negative x squared plus 12x minus 5. Any c value will work. So that one was nice and vague. I don't know if that was any benefit to anyone. It wasn't for me. And I have to give you another wonderful bit of eye candy, because I'm going to have to go and fix more slides. This is obviously going through the whole thing. Quadratics are commonly presented with 3 terms. For example, y equals x squared plus 2x plus 3. However, quadratics are not always trinomials. Sometimes they're binomials or even monomials. Consider the binomials y equals x squared plus 2x, or y equals x squared plus 3, or the monomial y equals x squared. The steps for graphing these quadratics are identical to the ones previously listed. A trinomial has 3 terms, where you have x squared, x, and a constant. A binomial has 2 terms, x squared and x, or x squared and the constant. And a monomial has only 1 term, x squared. Example 3, graph the quadratic y equals x squared plus 6. So first, identify a, b, and c. Use our formula, negative b over 2a, to identify the x-coordinate of the vertex. There's some more eye candy for you, because I thought I had fixed it and I missed one. Okay, let me grab my little pen, and we're going to go x equals negative b, which in this case is 0, over 2 times a, which in this case is 1. Because the b is missing right here, it has to be a 0, okay? Which means x is going to equal to 0, okay? That one is easy enough. So now we have x equals 0, and again, it's missing. I thought I went through and fixed these, but it really hates me. Substitute 0 for x in the original equation to find the y-coordinate of the vertex. So we have y equals 0 squared plus 6. 0 times 0 is just 0, so y equals 6. So now we have our value for y. The vertex is 0, 6. Okay, and if we're going to plot that, it would just be choop, choop. We're not going to go over on x, but we will go up 6, 2, 3, 4, 5, 6. I'm sure you missed my wonderful drawing abilities. That's where your vertex is going to be. An x value to the left of the axis of symmetry is -1. Find the corresponding y value by substituting 1 for x in the original problem. Come back, tools. I'm a tool. Okay. Nope, come back. Ha 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 ha. So we're going to say this time that x is -1. So we have -1 squared plus 6. -1 squared is just 1, +1. So y in this case is going to be 7. A point to the left of the axis of symmetry is -1 and 7. Since the point -1, 7 is 1 unit to the left of the axis of symmetry, a plot point 1 unit to the right is 1, 7. I'm going to show you that. So we know that our axis is 1, 2, 3, 4, 5, 6, because we already established that, okay? And we're going to go to -1 and up 7. So there's our next one. And then if we reflect it over, it's going to be 1 and +7. So we get a nice little happy face this time. Connect the 3 plotted points with a smooth curve. Hopefully all of my graphs are not missing because there's a lot in this. The previous example shows a quadratic missing the b term, which was why b equals 0. The same steps for graphing would apply if the c term was missing. Remember that the a term, which is the x squared term, cannot be missing. Otherwise, the equation wouldn't be a quadratic. Without the x squared, you don't have a parabola. Here's question 1. Graph the quadratic. Y equals 2x squared plus 12x plus 4. And this one you're going to work through on your own, and it's a miracle because the formula actually appeared. Pause the video, go do this, come back, we'll work through it. So the first step is to find the x-coordinate of the vertex and the axis of symmetry, and that is x equals -3. You find that by using the formula -b divided by 2a. Okay, -b is 12 divided by 2 times a, which is 2 for a. Okay, so 2 times 2 is 4. Okay, I went and dug it out for you again. This one is being a pain in the butt. Here's your graph. Okay, the y-coordinate of the vertex is y equals -14. The vertex is -3 and -14 because we found the values of x and y. To find the y-coordinate, you're going to take this x value and plug it into this formula, solve for y. The one point to the right is -2 because we're sitting at -3, so they picked -2. And the corresponding y value is -12, so 1 point on the curve is -212. You reflect that over, so you go 1 unit to the left, which will give you -4, -12. If this was hard for you or did not make sense, comment, say you need help on question 1 at the beginning, and I will make a video for it, okay? Question 2, the height in feet of an arrow t seconds after it has been shot can be represented by the function h of t is equal to -16t squared plus 80t plus 4. Find the maximum value of the function, then interpret it in the context. The maximum value of this quadratic is the same as the vertex because we know it's going to rise, the arrow is going to go up into the air, and then it's going to fall, so it's going to be a frowny face. Use x equals -b divided by 2a to find the x-coordinate of the vertex, which is 2.5. Then after substituting the 2.5 into the original function, the y-coordinate of the vertex is 104. Thus the vertex is 2.5 and 104. After 2.5 seconds, the arrow reaches a height of 104 feet. Again, if it didn't make sense, go ahead and, post down in the comments and I'll come back and do it. Practice question 1. Graph the quadratic y equals 2x squared plus 2x plus 4. What is the axis of symmetry? Pause it, try to do it yourself, then come back and we'll work through it together. All right, so the first thing we need to do is find the value of x, which means we need to do negative b, which in this case is 2, divided by 2 times a, which in this case is 2, which equals 2 divided by 4, which equals 1/2, okay? So this is our value for x, okay? I'm going to write it up here. X equals 1/2. Okay, I'm going to erase this now because we're going to run out of room. Now we need to figure out the value for y. So we have y equals 2 times 1/2 squared plus 2 times 1/2. Ooh, I'm doing so good. Plus 4. So y equals 2 times 1/2 squared is, I'm going to have to get a calculator for that. Let's be real, I'm not a math brain. It is 1/4. I was actually right, but I didn't trust myself. Plus, so 2 times 1 is 2 over 2. 2 divided by 2 is 1 plus 4. So 2 times 1/4. 2 times 1 is 2. This is really 2 over 1. 1 times 4. 2 divided by 4 is 1/2 plus 1 plus 4 equals, this is 5.5. 5 and 1/2. So y equals 5.5, okay? So we know our x and y. Come here, I got the eraser. Oh my goodness, I am just having a grand old time over here. It's a good thing you're cute, little ferret. It's a good thing. Now what we need to do is pick a value for x. So if I have, I'm sorry, little ferret, if I have my little graph over here, x is, I'm going to space that out a little bit. We're going to say x is right there and y is 1, 2, 3, 4, 5, 6. Okay. So it's like somewhere right here. Okay. That's our vertex. So we're going to pick 2, or I guess you could use a half, but I don't like halves. I don't like fractions. I don't like decimals. So we're going to pick 2 as my x value to try to find another point, the symmetry points, okay? So we're going to go 2 times 2 squared plus 2 times 2 plus 4 will give us y is equal to 2 times 4 plus 4 plus, I'm guessing that's a 4. I'm writing so sloppy. Y is equal to 8. 4 and 4 is 8. So y is equal to 16, which means that our point over here is going to be 2 and 16, which means the reflected point is going to be 0 and 16, I believe. Okay. What is the axis of symmetry? Oh, I didn't need to go that far. The axis of symmetry is right here. It's 1/2. This is the axis of symmetry. I went farther than I had to, which means eye candy time. All right, let's do practice question number 2. Graph the quadratic. And look at that, I'm missing a ferret. Graph the quadratic y equals x squared, the plus 2x plus 4. What is the y value for the y-intercept? So, like we've been doing, the first step is to do our x, find our x. X equals negative b, which in this case is 2, divided by 2 times a, which in this case is 1, which equals negative 2 divided by 2, which equals negative 1. So in this case, x equals negative 1. Watch me go. I am so magical, okay? And then our next step is to solve for y to get that much bigger. Okay, so we have y is equal to negative 1 squared plus 2 times negative 1 plus 4, which is then going to give us negative 1 squared. Negative times a negative is a positive, so we have just 1. 2 times negative 1 becomes a negative 2, and we add 4. Y is equal to 1 minus 2 is a negative 1, plus 4 will then give us 3. So y is equal to 3. Let's erase all this garbage, okay? And we're trying to find the y-intercept. Well, we don't have it automatically because the y-intercept has an x value of 0. So if we have our little graph right here, and we have x is negative 1, and y is 3, 2, 3, then what we need to do is we need to make x equal to 0 and solve for that. So we're going to go y is equal to 0 squared plus 2 times 0 plus 4. Y equals 0 plus 0 plus 4, which means y equals 4. Now, did I need to do all of this and find the vertex? Probably not. Wow, I'm so good. But you know, work harder, not smarter, I guess. Okay, this is quick check question 1 at the end of your lesson. I'm not going to answer it for you. I don't know if I've said this, but it's hard to like go do the quick check and then go back and continue the lesson. So I usually tell Angie to just write the answers down to these and then answer them at the end rather than trying to jump back and forth. Anyway, graph the quadratic y equals x squared plus 3x minus 8. What is the vertex of this quadratic? And then you're going to decide which vertex is correct. There's only one correct answer for this question. Quick check question number 2 says graph the quadratic y equals 4x squared plus 3x plus 8. What is the x-intercept? There may be 2 x-intercepts because it's possible for the parabola to cross it twice. Okay, it's possible for that to happen. So there may be one answer. Well, there's only one correct answer here, but it could be any of these. So select one of these, but any of them are a possibility. Quick check question number 3 at the end says determine whether the a value is positive or negative. Provide an appropriate reason. There's that graph back for you. So you'll look at this and then you'll decide which answer is correct here. Only one answer can be selected. And quick check question number 4 says which of the following is true based on the graph of the quadratic. And this one you may be able to select more than one. Okay. Second half of the lesson, converting from vertex form to standard form. It makes the most sense to use vertex form when writing the equation of a quadratic given a graph. Vertex form is y equals a times x minus h raised to the second power plus k, where hk is the vertex and a cannot equal 0. Once the quadratic is in vertex form, it only takes a few steps to convert it to standard form. Standard form is y equals ax squared plus bx plus c, where a cannot equal 0 and b and c are constants. So if you don't have these formulas written in your notes, you need them. Example number 1, convert the quadratic y equals negative x plus 2 squared minus 7 from vertex form to standard form. We're going to do this together. First, expand the expression. So this right here gets expanded to the negative drops down, and this can be expanded as x plus 2 times x plus 2. That's just what that squared means. Okay? So we're taking this and writing it as this. The negative drops down, then we have x plus 2 times x plus 2, and the minus 7 drops down. Okay? Next, we're going to multiply this out. The negative drops down. We have x squared, 2x, 2x, which becomes 4x, and 4, negative minus 7 drops down. Okay? Now we're going to combine like terms. First, we need to distribute this negative throughout, so this becomes negative x squared, this becomes negative 4x, this becomes minus 4, this becomes minus 7, okay? And then we can take minus 4 and minus 7 and combine them, and this is your final form. Okay? If that didn't make sense, go back, pause the video, go back and watch it again. Go through all the steps. These are all just basic algebra steps to do this. Okay? Here's a check-in. Convert the vertex form of a quadratic to standard form. If you feel like you can do it, pause it, go ahead and do it on your own, and then come back. If you need help, we'll work through it together. Okay? So, the first thing that we need to do is we need to take this section of the problem and expand it. So we still have y equals. We still have that negative, but now it's going to be x plus 6, and then it's going to repeat itself because it was squared. So x plus 6, and then that minus 7 drops down. We don't lose any pieces of our problem. Okay? So now we have y equals, the negative is still there. We have x squared, x times x, okay? Then we have x times 6, so 6x, and another 6x, so that's 12x. And then we have 6 times 6, which is 36, minus 7. Now we need to distribute this negative out, so we have y equals negative x squared minus 12x minus 36, and our subtract 7 drops down. Now we just need to combine these two like terms, so we end up with y equals negative x squared minus 12x minus 43, which is the answer right here. I wrote it down to make sure that I did not screw you guys up. Okay? How to write a quadratic in standard form. So this should go into your notes. And once again, it's all cattywampus, but I will fix it for you. So the first step is to identify the vertex of the parabola. Substitute the x-coordinate into h and the y-coordinate into k in the vertex form. Choose any point other than the vertex and substitute the x and y coordinates into the equation y equals a times x minus h squared plus k. Solve for a. Then you're going to write the quadratic in vertex form, which is y equals a times x minus h squared plus k. And then you're going to convert from vertex form to standard form, which is what we just did. Example 2 says write an equation in standard form for the quadratic graphed here, and it's a miracle because everything actually appeared like it was supposed to. Oh my gosh, everything appeared again. So the vertex of the parabola we can see really easily is -1, -3. Okay, so we're going to substitute the x-coordinate for h and the y-coordinate for k in the vertex form. So this is where h goes, this is where k goes, and we just substituted that in. Now remember, we have to change the sign on this. We learned that in the last lesson. So it's not -1 here, it's +1. Okay? Here's some eye candy for you so that I can start completely over. Okay, let's try this again. So we have y, which in this case is going to be -4, is equal to a times x, and our x value for this is 0, plus 1 squared minus 3. So for PEMDAS, we do the parentheses first. So -4 equals a times 1 squared minus 3. Now we do exponents. So we have -4 equals 1 times 1 is 1, so we have just an a here, minus 3. Let's add 3 to both sides, and we end up with a being equal to -1. Okay, so now we have our a value, we have h, we have k, we have a. The vertex form of the equation is y equals -x plus 1 squared minus 3. Okay, convert from vertex form to standard form. So in order to do that, we're going to go y equals, we're going to keep the negative, we're going to expand our square, so it's x plus 1 times x plus 1, and oops, get that 1 in there, and we're going to keep our minus 3. Now we have y equals, keep the negative, we have x squared. Let's get our parenthesis back in there. We have 1x and we have 1x, so 2x. Dad Bob got up. And then we have 1 and 1, which is 1 plus 1, close the parenthesis, minus 3. Now we have y equals, we need to distribute this negative. So we have negative x squared minus 2x minus 1 minus 3. Then we have y equals negative x squared minus 2x minus 4. And this is our final form. Okay. Convert from vertex form to standard form, which we just did. Okay. Here is a check-in. Write a quadratic in standard form that has a vertex of 2, 1, and passes through the point 1, 4. You should be able to do this on your own. Go try and then come back and we'll go over it. Okay, so you should have y is equal to 1/3 x squared minus 4/3 x plus 7/3. This one's kind of hairy because it's got fractions in it. If it was hard, go ahead and write down that you need the check-in that's kind of this puke beige color, and I'll go back and do a video for you. Okay. Example number 3. Write an equation in standard form for the quadratic graphed here. We'll go through this together. First, find the vertex, which is -3 and -5. Substitute the x-coordinate for h and the y-coordinate for k in vertex form, and that's going to give you y is equal to a times x plus 3 squared minus 5. Next, another point on the parabola is a -2, -2. You can see it right there. Substitute those values into the equation to solve for a. So how you do that is you go -2, because that's our y value, equals a times -2 plus 3 squared minus 5. We do our parentheses first, so we have -2 equals a, -2 plus 3 gives you 1, which will then be squared, and we'll subtract 5. -2 is equal to 1 squared is 1, so this becomes just a minus 5. We're going to add 5 to both sides, so a is equal to 3. Okay. You can see here we have our value for a. The vertex form of the equation is y equals 3, because there's our a, x plus 3, because we already knew from the vertex what our h value was, squared, minus 5. Remember, you have to flip the value, the sign, the negative sign, positive sign for h. Write an equation in standard form. Convert the vertex form to standard form. This should be our final answer. Let's make sure we can do it. So we have y equals 3 times, we're going to expand this, x plus 3 times x plus 3 minus 5. Okay, parentheses first because of order of operations. So 3 times x squared. We have 3x and 3x, so that's 6x. And 3 times 3 is 9. And we're going to subtract 5. Now we need to distribute this 3 through the whole thing, so we have 3x squared plus 3 times 6 is 18x. And 3 times 9 is 27. Minus 5. We just need to combine these like terms, and our final formula should be 3x squared plus 18x plus 22, and we did it because we're smarty pants. Here's question 1. Write a quadratic in standard form that represents the graph. We can do this together. You can go ahead and try it on your own and come back if you want to, whatever you want. The vertex of the parabola is 1 and -2. That's right there. Substitute x for h and y for k in vertex form, which means that x is -1, because remember we flip the sign for h, and y becomes k, which is -2. Okay. Another point on the curve is 0, 0, which is right there. Substitute the x and y values into the equation and solve for a to get the result. So we would take this formula and we would substitute 0 for y and 0 for x and solve. The vertex form of this quadratic then becomes y equals 2 times x minus 1 squared minus 2. And then when you split this out and do all your math, you're going to end up with the vertex form y equals 2x squared plus minus 4x. Okay, let's do question 2. Describe and correct the errors in converting from vertex form to standard form. Pause the video, look at this, see if you can figure out where they went wrong, and then come back. Okay, so in step 2, the x minus 1 squared is valued incorrectly. It should have been split into x minus 1 times x minus 1, which when you multiply it out becomes x squared. And then we have negative x and negative x, so minus 2x. And then we have negative and negative, so positive 1. And they got this garbage instead. Here, -4 coefficient is not distributed correctly to both terms, because once we have this, then you're supposed to take -4 and multiply it out. So then it becomes -4x squared and positive 8x and -4. So they did well on step 1, but the rest of it was just kind of messed up. So practice question number 3. Convert the quadratic y equals 2 times x minus 5 squared minus 10 from vertex form to standard form. The standard form of the quadratic is what? Okay, so pause the video. Go do this on your own. This is at the very end of the lesson. Then come back and we'll double check and make sure you got it right. Okay, so this is what the graph looks like. A. So first we do the parentheses, which is -1 equals A times, do we really not have an X? I'm doubting myself. I'm just thinking about earlier in the lesson. I'm being silly. So we have x minus 3 times x minus 3 plus 1. And this should just be y. I started out bad because I started out with the wrong formula. I copied it off the wrong page. Okay, there. Let's try this now. Okay, so now we have y equals a, which we don't know what it is yet, times this becomes x squared. And then we have -3x, so -6x plus 9 plus 1. Okay, and maybe I don't need the a. I'm really doubting myself now. So do we have x squared minus 10x plus 10? Is that our final formula? Is it? Because a should be positive because it's upward. We're just going to assume that's right. If it's wrong, let me know. Okay, let's try this one. Write the equation of the quadratic function in the graph in standard form. Okay, I'm going to take it slow this time, make sure I'm getting all my steps. The formula is y equals a times x minus h squared plus k. This is the formula we're using. So the first step is to take our vertex, which is right there, and substitute it for h and k. So that would leave us with y equals a times x minus We have to flip the sign for h, which is negative 2 here, so it becomes positive 2. Okay. Squared plus k is going to be 5k. Okay, it's starting to make sense to me now. We know that because it's downward facing, that this a is negative. So we're going to have a negative here. We need to expand this, so it's x plus 2 times x plus 2 plus 5. Okay, now we have y is equal to, keep the negative, we have x squared because we have x times x, and then we have 2x and 2x, so plus 4x. And then we have 2 times 2, which is 4, plus 4, plus 5. Now we need to distribute this negative out. So we have y equals negative x squared minus 4x minus 4 plus 5. And our final formula is going to be y equals negative x squared minus 4x plus 1. Okay, that all made sense to me now. Question 4 was a hot mess. Sorry, you know me. Okay, quick check question number 5, which is the last one. Convert the equation from vertex form to standard form. There's your formula. Use your steps that are in your notes, and you can go ahead and complete it. And how many times did I screw up? I knew I was going to screw up. I just didn't think it was going to be like double-digit bad, but it probably was. And I'm going to go ahead and put some fun videos on here because I feel like if you did algebra for this long, you deserve to go and watch some nonsense. Okay, bye.